All right. Hello. Summer 7.6. That is 7th grade material, chapter 6, dealing with percents. So it says write 46% as a decimal. Use a model to represent the number. Well, we have this 10 by 10, which has 100 boxes in it. So when we see 46%, 46% is 46 out of 100 boxes that will be shaded. And then if we had to write this as a decimal, that would be 0.46, 46 hundredths. So when it's in the denominator, we put a TH on the back there. So that's the hundredths place. Hundredths. So we have 46 hundredths. And then we would do, well, this will be 40 of them. So we would shade all down in here. That would be 40 boxes. Now let's do this. That's kind of messy. So let's do a highlighter. So that would be 10 boxes, 20 boxes, 30 boxes, 40 boxes, 1, 2, 3, 4, 5, 6. So that would represent 46 100ths. Okay, so as a this is as a fraction, not reduced. We could also reduce this. This is it as a decimal. Write 66.6 repeating as a decimal, round to the nearest thousandth if necessary. So we're going to write this as a decimal. So as we notice, let's go back here. We notice that the decimal point of 46%, so when we write 46%, that decimal point is there. And notice where it ends up. So when we convert it to a decimal, percent to a decimal, we actually move that decimal point 2 places to the left. And so we notice that it ends up between the 0 and the 4. So if we use that trick, when we have 66.6 repeating, let's write it correctly, 66.6 repeating, well, let's think about that number. That is 6, 6, 6, 6, and it just keeps going. And the way that we represent that is with the 6 repeating, with the repeating sign over the 6. So if we take this decimal point and move it 2 places to the left, well, there's going to be a 0 there. So if we were going to write this as a decimal, the proper way of writing it would be 0.6 repeating. But notice it says round to the nearest thousandths if necessary. Well, technically it's not necessary. We don't have to round it. This should be the answer. Now, if we do round it to the nearest 10 thousandths, so we can write this number excuse me. Sorry, hopefully that didn't make you jump out of your skin. So let's look at this. This is the ones place. This is the tenths, the hundredths, and the thousandths place. So when we round to the nearest thousandths place, we're going to round to this location, but we have to look to the right to see if we're going to round this number up or hold it at 6. Now, because this number is 5 or more, we're going to round this thousandths place up to 7. Sorry, we're going to round it. We're going to hold it to 6 or round it up. So the other answer that I would assume that you might see is 0.667. That would be, I guess, the answer that they would look. Describe a model representing the number 10 by 10 has how many squares shaded? It has 66 and 1/6 of 2/3 or 6/9. It's not 6/10 because repeating. So we'll go over that. So that would be 66 squares and 2/3 of 1 square shaded. Here's something that's important. So when we have 0.1 repeating, that equals 1 over 9. When we have 0.2 repeating, that's 2 over 9. 0.3 repeating is 3 over 9, which reduces to 1/3. 0.4 repeating, 4 over 9. 0.6 repeating, which is what we have, is 6 over 9, which reduces to 2/3. So that's why I wrote 2/3 of that last square. 7 repeating is 7 over 9. 8 repeating is 8 over 9. And now we can do something like this. If we have 0.11 repeating, that is actually 11 over 99, which actually equals 1/9. Because 0.11, that's so funny. I did that. That's such a bad, you would never see that. This is actually this. Because repeating, that was kind of dumb. I was thinking of a number, a 2-digit number. So you wouldn't write that. You wouldn't write 112 because that can be simplified. So we'll do this one. That's going to be 13 over 99. So when you have 2 digits repeating, it's 2 9s. When you have 3 digits, let's do 104. That's going to be 104 over 999. Okay. So those are kind of fun, interesting. Again, we do not write this. This will never be written like this because 11's not repeating, 1 is repeating. This is a no. Big no-no. That cannot be written like that. Anybody writes that, tells you that that's correct writing, that is not correct. That is always written like this. This is the only way you can write that. A little bit of a tangent, sorry about that. Write it as a percent, so 0.18 is 18 over 100 because it goes out to the hundredths place. We're going to reduce that. Oh, no, we don't reduce it, excuse me. If we want it as a fraction, but as a percent, hello. This is a fairly rough video today. Sorry about that. But as a fraction, it would be 9 over 50, but it wants it as a percent. So we noticed that when we converted a decimal to a percent, we moved it 2 places to the left. Move 2 places to the left. And when you convert from a decimal to a percent, we're going to move it 2 places to the right. So the opposite. We're going to move that decimal point 2 places to the right. Move 2 places to the right, which creates 18%. And that is 18 out of 100, so we would shade. We'd shade 10 and then 8 more blocks. So that would be the representation of 18% of this is shaded, or 18%, 18 over 100. All right, let's see here. We've got right 2.3 repeating as a percent, round to the nearest tenth if necessary. So remember, we moved this decimal point 2 places, 2 places to the right. We're going to add a 0, not a 0. Oh, super rough. It's Saturday morning, so I thought I'd get a little work done. And this is clearly, my brain is yet to be started, so keep in mind. Okay, so we're going to move it 2 places to the right. Since it's 3 repeating, it is not a 0 to the right of there, it's 3's to the right of there. So that's going to be 233.3 repeating percent. And then it wants us to round to the nearest tenth. So if we're going to round here, we will underline the tenths place, and we will look at the hundredths place. That number is below 5, so we will hold 3. So the correct answer is 233.3% would be the rounded answer. This would be the exact answer. And if we had to describe the model with 233 fully shaded blocks and 1/3 of the squares of the of the of the third grid shaded. Oh, got it. Sorry. They're saying how many 10 by 10 grids would you have shaded? We would fully shade 2 of them. And then we would shade 1/3 of the third grid. So you have, that's 100, that's 200, and then you would have 33.3 shaded. So it kind of looks like this. That's 100, that's 200, and then that's 33.3 repeating shaded. All right. Write the fraction as a decimal and a percent. Okay, this is what we really want to be working on. So as a decimal, so 7/10, notice it goes to the tenths place. If we make it a percent, well, there's 2 things we can do here. 7/10 is equal to 70/100, and we know percentages are always out of 100. So that would be 70%, or we can take our decimal and we can move that decimal point 2 places. This time it's a 0 because it's not repeating. So that would be 70%. Both techniques work. Write the fraction as a decimal. We know that when we have 9, that's going to be 0.5 repeating. So 1 digit, 1 9, that's going to be, the numerator will be what's repeating. And our answer is going to be this one. Yeah, and then as a percent, we would move it 2 places. So we have 0.5 repeating, which means 5, 5, 5. So when we move it 2 places, we get 55.5 repeating percent. And that would still be this one. So both of those answers are correct. Write a fraction as a decimal. Okay, that's good. So this isn't over a base 10 number. So I don't want to divide it by a half. I could, and I could get 3.5 over 1,000. And then we can take the 0 off and we can get 0.35 over 100. You know what I mean? Divide by 10, divide by 10. So we could look at this as a decimal as 0.35. And then as a percent would be 35%. No, that doesn't make sense. That doesn't make sense at all. Oh, because that's not it as a decimal. Hello. Because, sorry. This is a percent. My percentage would be 0.35 because it's out of 100. That's what's in the numerator there. But my decimal value, I would need to make it over 1. So bring it 2 more spaces over, or we can convert it and bring it. So it'll be 0.0035. So if my decimal point is there, 1, 2, yeah. So this is the decimal fraction, would be that. And so we could do, watch this. We can move this. We can move this decimal. So this is equal to 3.5 over 1,000. Yep, just like this. And that's equal to 35 over 10,000. And this is 35 10,000ths. So notice 35, tens, hundreds, thousands, 10,000. So this is 35 10,000ths, which is correct if we moved it that way. If we move it the other way, we end up with the same number over 1. So this is your percent. This is your decimal value. Write a fraction as a decimal, so I kind of want it as a over 100, over 1,000, over something, over 1, etc. So this is kind of hard because it's going to be a repeating decimal. There's two ways we can do it. We can divide 15 into 17 and see what decimal we get. Put the decimal, 15 goes into 17 once, 2, bring down the 0, 15 goes into 20 once, with a 5 left over, bring down the 0, 15 goes into 50, 3 times? 3 times 45. And we keep getting 50, so it's going to be 3 repeating. So this is equal to 1.13 repeating as a decimal. If we make it a percent, we move it 2 places. So the decimal, or the percentage, would be that. So we want 1.13 and this one. So my answer is this. Good. Okay, I like that. That's the easiest way to tackle that. An astronaut spends 53% of the day working. 0.1, not percent, it's not 0.1%. It's going to be, if we change this decimal to a percent, it would be 10% of the day eating and 30% of the day sleeping, and the rest of the day exercising. So we got 53, 63, 93, so that would be 7% left. Order the events by duration from least to greatest. Justify your answer. So least to greatest. So least would be resting. The rest of the day exercising, sorry. So the least would be exercising. The next one would be eating. The next would be sleeping. And then the last one would be working. Okay, least to greatest. Least to greatest would be exercising, eating, sleeping, working. Explain, because we converted all these different formats, decimal to a percentage, fraction to a percentage. We already had a percentage, and it's going to be your full day is 100%, so 53, 63, 93, and then the 7% remaining to get me to 100. A band plays one concert in Arizona, one concert in California, and one concert in Georgia. In California, the band earned 3/2 the profit, 1 1/2 the profit that they earned in Arizona. Okay, that's 150%. Of the total profit earned by the band, 32% is earned in Arizona. How many times more money did the band earn at the most profitable concert than at the least profitable concert? Okay, this is a little bit tricky because you have to keep track of stuff. So plays one concert in Arizona, one concert in Georgia, and one in California. The band earned 3/2 the profit that they earned in Arizona. So Arizona is X. California would be 3/2 X. Of the total profit earned by the band, 32% is earned by Arizona. Now, this is the relationship between these two. Don't get confused with this. This number, this is 32%. So this is 32%. And then the other two are going to make up the 68%. So these two are going to be 68% of the earnings. They have to add up to 100. How many times more did the band earn at the most profitable concert than the least profitable concert? So Arizona, so it's 32% of the total. Okay, so maybe it is as easy as that. Okay, so 32%, and then they did that. So let's multiply that by 32 times 3 over 2 gives me, we're going to cross cancel because we like to make our numbers smaller, 16, sorry, green, and that's going to be 16 times 3 is 1848. So that's 32%. California is going to be 48%. And then Georgia, because the total between those is 38, so Georgia is going to be 20%. 20%. Okay, so that adds up to 100. That's good. And 48 is 1 and 1/2 more than 32. Yeah, that's half of that is 16. 16 plus 32 is 48. Yeah, good. So how many times more? Well, it's 1.5 times. Oh, no, sorry. That's not between. So this was between Arizona and California was 1.5, but they say what is the least to the most? So least to the most is going to actually be 48 over 20. 48 over 20 gives me 24 over 10. So that's going to be 2 and 4/10, 2 and 2.4 times as profitable. So Georgia was 20, 2.4 would give you 48, which is California. California was the most profitable. So we make that over 100, so 240 or 2.4 times as profitable. Yeah, I like that. That's 240%, which is 2.4 times, which again, as a decimal, gives me 2.4. Find the missing dimension, use the scale. So the figure skater scale is 1 to 15. So the model and the actual, so 1 to 15, we're going to assume that the model, this is the model, this or what we call scaled. I like scaled. This is the scaled value. This is the actual value. So we're going to put 67.5 in for actual because that's the actual, and we want to find its x. So 15 times x equals 1 times 67.5. 15x equals 67.5. We'll divide by 15. Divide by 15. And we should get x equals, let's do some math on the calculator. 67.5, whoa, cancel it. 67.5 divided by 15 gives us 4.5. Okay, 4.5 inches. So the model, the figure skater would be 4.5 inches. Find the missing using the scale. So model actual, the model is 5, so we do the same thing as we did before. We have 1 over 15. This is the scaled value. This is the actual value. So our scaled value is 5 feet over x. And we don't have to do cross product because we can go from the known to the unknown. And I see that I'm multiplying by 5. 1 times 5 gives me 5 feet. 15 times 5 gives me 75 feet. So the actual pipe would be 75 feet. Simplify the expression. I like this. These are, we have parentheses, so we're going to try to do what's inside here. We can't simplify. These are unlike terms. So we still have this multiplication out here, so we're going to use the distributive property. 2 times 3p plus 2. Notice this negative doesn't go to the 2. My 2 is positive. So we should have a positive sign. So negative, or 2 times 3p, 2 times negative 6. That negative is attached to the 6. It better stay with the 6, equals 4p. I don't like this term expression because there's an equal sign that's confusing. 2 times 3p is 6p. 2 times negative 6 is negative 12 plus 4p. We have like terms, so we're going to combine those. That gives us 10p minus 12, and that's our answer. We can't add these two together. These are unlike terms. These are pipes, and these are dollars. Simplify the expression. This is good. What are we simplifying? This is a place where a lot of students make a mistake. They distribute out the 3, but this is a negative 3. So we need to distribute a negative 3 into that parenthesis. So we'll distribute the negative 3 to both of those terms. We get 5n minus 3 times 4n minus 3 times 1. That negative goes with the 3. I'm distributing that. I want to see it in both, and we're distributing it to both of these terms, 4n and positive 1. Now we'll simplify. Negative 3 times 4n is negative 12n. Negative 3 times positive 1 is negative 3. We again have like terms. I have 5 nunchucks and I have negative 12 nunchucks, which makes negative 7 nunchucks, minus 3. What is the solution to this? So this is an inequality. We're going to isolate. We got to get rid of things being added and subtracted before being multiplied. The negative 4 and the positive 4 cancel. We have to balance the equation, and we get negative 8. Now we get rid of 2 multiplying by dividing. N is greater than negative 4. N is greater than negative 4. That would be our answer. I don't think it asks us to graph it, so we're good. Comparing numbers in different forms, which number is greater? So we'll convert this to a decimal. That's 4.4 tons. And this is 4.3 tons. So which one is greater? Is going to be the 4.4, or 4 2/5 tons. Comparing numbers, which number is greater? 82% success rate, or 5/6 success rate. So we could divide 6 into 5, which goes 0. 6 goes into 50 8 times. 6 times 8 is 48. Goes 2, bring down the 0. 6 goes into 23 times. 18 goes 2, bring down the 0, and that would be 3 repeating. So this would be, as a decimal, would be 0.83 repeating decimal. And then if as a percent, we would move it 2 places to the right, 1, 2, and that would give us 83.3 repeating percent. So 82%, 83.3 repeating percent. So which one is, comparing numbers in different form, which number is greater? This number is greater. So we converted it. We see that's our explanation. 26% as a decimal, that's going to be 0.26. We move that decimal point 2 places to the left. And to represent it as a model, that would be 26 shaded squares. So we got 10, 20, 2, 4, 6. That would be 26% of it shaded. 63 is a percent. 0.63 is 63%. 63%, we would move that decimal point 2 places to the right, and 63% would be 63 boxes shaded. So that's 10, that's 20, 30, 40, 50, 60, 1, 2, 3. 63% of the boxes shade. 9% as a decimal is 0.09. we're going to take that percentage and we're going to move it. We're going to move it 2 places to the left, 1, 2. So we have to put the zeros in there. And shading wise, we're only going to highlight 9 of them. So we don't even highlight an entire row. 9 of 100. Okay, now let's start checking our answers. 46% looks pretty good. 18. Oh, look at that. That's very interesting how they went left to right and I went up and down. Both are correct. Yep, that's this one. 0.5 repeating. Yes, 0.035. I like that. We talked about that. That was a good tricky one. 1.13 repeating. Yep, that's good. We got that correct. So the correct answer is exercising, eating, sleeping, working. Yep, going from smallest to greatest. Smallest was exercising, which was 3%. Eating was 10%. Sleeping was 30%. Working was 53%. 2.4 times. Good. We like that. We did that correct. 4.5 inches. Yep. We got that as the scaled version. And this 75 feet as the actual 10p minus 12. Yep. Negative 7n minus 3. Yep. And then we got n is greater than negative 4. And 4 2/5 tons was greater than. That was 4.4. And yes, that was 83.3 repeating. Something of that nature. Good. Okay. Also, and last two, sorry, 0.26 and 63 and 9. Yep, 9 of the 10. Okay. Hopefully you like that. Hopefully you were successful. Those are good problems. Those are just the basic foundation problems that you should be confident in and understand how to manipulate it back and forth.